Sorry, I'm just looking over my shoulder. You probably see the mist rolling in here. We're in Hilton, which is where our headquarters are, and it's like gorillas in the mist here. So we're doing the shoot right now. Weather's rolling in, but hey, you know what? It's all part of the deal.
In a land of beauty and danger,
This is as close to God as you get.
she risked her life.
Motor. Oops, almost had an accident there, but anyway. Let's just get our camera set up. Sorry, we are shooting outside, but hey, this is the real deal. This is no choreographed stuff here. Are you good there? Yeah. Carl? Cool, man. Anyway, a bit of a chuckle for anybody out there. No cameraman was injured in this process. Welcome back to Tech Chip Tuesday. So I hope you guys enjoyed. If you watched the Epicenter video, which was Bring Back the Bass, certainly a lot of people enjoyed the 70s tunes. And if you have any questions on that, please feel free to contact us. Happy to answer any of your questions. But today we're going to talk a little about something that I mentioned in one of the videos, and that was amplifier current. People are often misconceived about wattage and how many watts an amplifier is, and you see these big numbers, 27,000 watts and 50,000 watts, and and you look at these things and you go, who really knows the truth? Companies continually produce products and they just lie about the stats. Well, they lie, but they also, let's just say, are they lying or are they just not telling the full truth? And it's kind of a bit of both, and I'll tell you where it comes from. Because if you're going to rate an amplifier and you're rating it on how much it can produce in 1 second, it doesn't say how long it did it for. So it might say it does 1,000 watts, but maybe it only did it at one frequency into a fixed resistive load, which is not like a speaker. A speaker is a reactive load, which takes about 6 times the current from an amplifier than it would do from just a fixed resistive load. And if you were to, play it for a millisecond, it could do that number. So they can advertise it. But in the real world, for us, it's more about trying to get people to understand what wattage really is. And it comes down to one thing. Power is the result of two things, and that's current and wattage, amperage in other words. So we've set up a little meter here, a little TPI, and I've got 3 batteries. Okay, I've got this little 12-volt remote battery that you get in your remote, a key fob. I've got a typical gate motor or alarm, a gate motor battery or alarm battery, and I have this big-ass car, or in this case, truck battery. And obviously, I think it's common sense to think that little guy we all know, which is 12 volts, and I'm going to show you now, would not start a motorbike, yeah? And this here, it might open a gate or start a motorbike, but it's certainly not going to start a car. And this car battery may start this car, but it wouldn't start a truck. So just to confirm that we are not giving you smoke and mirrors, if you look over here, I'm putting the multimeter to the test, and it shows me, let me get the probes on properly, 12.34 volts. That is it, 12.34 volts. Yes, it's DC. We understand that, direct current. This little guy here also is producing, let's have a look. That one's producing 13 volts. Okay, it's just had obviously a bit more charge, but it's meant to be a 12 volt at rest, but obviously it's just had a little bit of a charge. I've just taken it out the alarm system, and it's sitting at 13 volts at rest. This car battery, on the other hand, is also giving me, what are we getting there? 12.36. Ironically, virtually the same as this little tiny remote battery. So then you start thinking to yourself, well, what's going on here? They all got the same voltage, and I'm going to show you a little bit of maths just now. We're going to go to the whiteboard, and if you took this voltage, and assuming it was AC power supplies, which it could easily be, it would be, so how do you calculate wattage? Wattage of an amplifier is created by V squared over R, kind of basically Ohm's law. So you could take this voltage, which is 12 by 12, which is 144 watts, 144 volts, divide by the impedance, which is the R, the load. So it's 12 by 12, 144, and let's just say the load was 1 ohm, okay? That would give you 144 watts, yes? And now you'd be thinking, well, all of these are 144 watts. But which one is more powerful? Well, we all know it's the big battery. So think of the amplifier as the same thing. So when it comes to an amplifier, it's all about the power supply, the current, how it can actually produce that wattage and control and move that woofer. Now remember I said earlier, it takes 6 times the amount of current, 6 times, to actually generate that wattage through a reactive load. Reactive meaning it's reacting. Essentially what you're asking yourself is, well, if this is the case, then it's much the same as your circuit breaker. If you look at your circuit breaker on your DB board, you've got 2 amp and 3 amp and 4 amp. You know you can't connect your stove to the 2 amp, but it's all 240 volts, or in the case of the United States, 110 or 120. But you cannot get the current to power those devices. Same as your cell phone charger. You know, it produces a small amount of amperage because it doesn't need to produce a lot of amperage. It's exactly what's going on in an amplifier. So when people tell you that this amplifier can do, you know, smoke and mirror numbers, ask yourself the question, you know, what is the current? So we're going to now show you what an amplifier dyno is. We've got a PMX2, which is just our little source unit that we sell, that we, you know, integrates into marine. Essentially, it's got the DNA of Rockford amplification built into it. And that's just to give you an idea of what Rockford power is all about. And I'm not saying, you know what, Rockford's DNA is started from the 70s, which is all about their existence to this day. The word punch and the punch EQ, which is patented. We've got trans-ana circuitry. We've got Mesa, which is something that, you know, is an amazing circuitry design. Different class of amplifiers. You've got A-class. And, you know, A-class amplifiers, just to mention this, is one of the most audiophile amplification classes, but it's not efficient. So it's normally used for home audio. And then you've got B-class, which is the typical cardon variety. So you'll get an AB class amp. You know, and B-class amplifiers are pretty noisy. They've got switching noise because the output devices are switching on and off, the transistors or the FETs. And then, of course, you've got C and D. D is like your typical low-frequency amps because they're super efficient, but they're damn noisy. They have improved over these days. You've got full range. Back in the day, they were only, you know, low frequency because they had big chokes to kind of kill the low frequency, kill the noise that you would normally hear. Rockford's obviously said, how do we get the best out of two? So we've developed AD class. Now those are things that some people don't even take into consideration. Besides, I can go on for days about the different patterns, but I think today we'll keep it simple and we're going to just demonstrate to you, you know, how this can be shown on an amplified dyno. Now an amplified dynamometer is kind of like taking a car and putting on a dyno and showing the true kilowatt power. We've got one of these devices, but except it's for amplifiers. And it's called an AD1, invented by Tony Diamore Engineering, who actually at one point worked at Rockford, and he invented what's called the 15kW. The 15kW was the most powerful full-range amplifier, the most efficient ever made. And if any of you go and look up, and we'll show you on a screen now, a thing called a Power Cube device actually developed in Sweden, and it shows what an amplifier does in a three-dimensional way. So it shows you its current, its wattage, and it's relevant to impedance. So obviously the impedance and how it reacts with a speaker is what an amplifier's true ability is. Now, we've got amps that are referred to as constant power, CP. CP means that obviously if anyone knows, and we'll show you inside, we're going to take a speaker, we'll move it up and down, you'll see the impedance moves. Now obviously if the impedance moves, it means the amplifier's output's affected. Now I can show you with a little bit of an Ohm's law calculation by taking two speakers and wiring them and say they're 4 ohms in series, we'll get to 8 ohms. If I wire them in parallel, it'll be 2 ohms. Now, if you go and look at that hose pipe over there, just go across to there, that's a thin-ass hose pipe, right? Next to it's a fire extinguisher. That fire extinguisher, which one would you choose to put out the fire if this building, God willing, doesn't go down? You would choose the fire extinguisher. Why? It's got more volume, it can let out more water. That's the same thing when it comes to, impedance. If you reduce if you raise the impedance, you get more resistance, which means it'll be that little hose pipe. If you reduce the impedance, you can get more power out of the amplifier, but you've got to feed it with more energy, which means you've got to have a big ass pump or a big water source to feed that. So it's the same thing when it comes to working out what an amplifier can do. So running it into 1 ohm is all very well and good, but can the power supply on the amp deal with it? And can it deal with it in the real world? In other words, can it provide enough current to that power supply, which means if the battery system is inadequate or the charging system, and it all comes back to the fact that you can spend, money and then obviously spend more money on wiring and batteries and everything to feed this thing. Whereas if the amplifier was designed properly in the first place, with a very efficient power supply, good components, and it produced what it was intended to do, not only will you get more longevity because the amplifier is never going to run to its full capability, it was engineered for real world applications, driving loudspeakers. And that's what we do. And bearing in mind, they're coming from the most unlikely power source of vehicles, charging system, which was engineered to drive the car, never engineered to drive a sound system. So you adding on extra demand is a problem. And of course, there's no spaces in these modern cars. They've got, all kinds of CAN bus integrations, and they've used up every little bit of space because of fuel saving, and that's a whole nother subject for another day. So we've got to figure out, how do we get good sound out of these vehicles with limitations in terms of the electrical system and limitations of space. So acoustically it's a challenge, which means your woofers are going to work in super small enclosures, which makes them non-efficient. If they're not efficient, then you need a very big amplifier, which is going to be, when I say big, I don't mean in physical size, I mean in wattage capability and current, to drive those woofers properly. And if you don't, you're starting off on a back foot. So guys, when you're out there, or ladies, because hey, let's be honest, it's a free world out there. Ladies, guys, I know there's a bazillion different, I don't want to get into that subject, but let's just keep it simple. Yeah, anyone, whoever what you are, whatever fits your fancy, you still want to have good stereo from the day you're born to the day you die. It is what it is. We have music at funerals, we have music at weddings, we have music at parties, we have music, at movies. Everything is connected, and if it doesn't sound good, you can hear it. The human brain is incredible at identifying when something's missing. It also can fill it in. And when you get that goosebump moment, when it sounds real, it's because everything's tied together. The amplifier is real. The woofers are in the right size enclosures. They're acoustically set up. And we're going to talk more about this, Dan, as we carry on Tech Tip Tuesday. We're going to talk about acoustics and speaker placements and crossover points and, the correct wiring configurations. And we're going to get into impedances and all kinds of exciting stuff. So, hey, I know I got a little bit off the rails there with, getting into it, but I wanted you to understand where we're heading and why this is such an important subject, understanding current. We have the resources, we have the technology, and we have the history, and we have the name brand. You know what? When it comes to brands, it's key to everything, So this is kind of where this is such an important subject. So we're going to head on inside. It's actually getting pretty cold out here. I wouldn't believe it's summer. However, we're going to head on inside, and we're going to start up there. First of all, I'm going to do some sums on the board and show you how to get to wattage, so you can see it in a practical way. And then we're going to start looking at the amp dyno and take a little PMX2, put it on the amp dyno and show you what this thing does. It's rated into 2 ohms, 50 a channel. And you say to yourself, how can that thing be 50 a channel? And then how can a power mini amplifier also be 50 a channel? All about current. We understand the limitations. See you inside, guys. We have this whiteboard here, which I'm going to kind of demonstrate. I'm lefty, so hey, excuse the writing. So we spoke about 12 volts, right? So 12 V, okay, and we're trying to work out wattage. So wattage is our goal, watts, okay? 12 V, which is, we said the formula is, let's do it over here, V squared over R. So we're going to make R 1 ohm, and the V is 12 volts, right? So we're going to say 12V times 12V equals, all of you should know, if you all went to school, 144 watts, right? 144 volts in this case, not volt, watts, we haven't got to that yet, 144 volts. And since the impedance, or the resistance that we have, because we've got, say, 2 woofers, they're wired in parallel, and this, remember, this is not, I understand, in case anybody's wondering, and they're saying, yeah, but it's DC. Yes, we know that. We're using this as an example. It could be AC power supplies. It makes no difference. What comes out of an amplifier, we all know is, well, hopefully you all know, AC voltage is what comes out of an amp. It feeds DC into it, and it basically inverts it in music with real time to become, so it's like your inverter for your home power supply for running your house. You can have DC inverting to AC, except it's at a fixed voltage. With amplifiers, they're producing variable voltage relevant to the signal, which is the music, right? So it's even harder for it to deal with it. But this is to do with explaining current, and it's to do with DC voltage as the example, but it's essentially representing the exact same thing as if it was AC voltage. So 12 by 12 equals 144. Now we divide that over 1, which is obviously the load, impedance. Okay, so we're going to call that our resistance. Is it dividing 1 into 144, which is 144 RMS, okay? And we now want to figure out, well, what's the max rating? Now, there's a number for that too. It is 1.414 approximately. And you times those two together, 144 times 1.414, I get 203.61 watts. We're just going to call it 204. Let's just say that little small starter battery or that remote battery was inside of an amplifier casing. Okay, and it looked the same, and it had terminals coming in it, and it had 204 watts per channel, because there was 4 of those in there. That's it. And they're going to lie and say, well, it's close enough to, we'll just call it 1,000. No one's going to really catch it. 1,000 watts. Obviously, they're going to sell it thing very cheap, right? Because so you've got 4 of those little remote batteries in. And then, of course, you've got the other little, battery that you saw, which is the gate remote battery. Guess what? It's also 1,000 watts, but it's going to cost more money, right? Because the other one was like 500 Rand. And obviously, the remote battery ones, which you're going to put 4 of those, they're going to sell at 1,500 Rand. But the other amplifier, which has got super sophisticated current, is going to be the car battery. And bearing in mind, car batteries might be physically larger, but now you've got, all kinds of technology. And that would have been 2,500 Rand. But they're all the same wattage. Which one would you have bought knowing what you know now? You may have bought the 500 Rand one because it still said 1,000 watts. And it looked the same, it's got the same terminals and everything's cool. And you'd be like, bargain. What you didn't know is you didn't have the current. And that's where you can get duped. Things should be measured. They should be measured accurately. They shouldn't just be marketed and, buy it because we said it's so. It's simple. It's all about current. And it's so easy to lie when it's, not being the issue that people are referring to. The biggest problem in any technology is heat. And if you can get rid of the heat, just like our bodies, you get rid of the heat. From a car, you get rid of the heat. You can't get performance. When you're hot or when your car's hot, you run out of performance. So an amplifier, it's got to have that. So with Rockford amps, they're all cast aluminum, which means cast aluminum is far more efficient, more expensive to make at getting rid of the heat. Also, they're computer design. They're not just something that looks cool. So people often say, well, why haven't we changed our design for a while? Because it's a perfect design. Internally, it continually evolves. That amplifier is perfect in its design, it's its functionality. And yes, it's all about the technology. You're listening to it. So don't get caught up by the... Anyway, well, this is the facts. So once you educate yourself into understanding it, hopefully when you go out there and make the next purchase, there are some questions that are going to put some people put a little bit of egg on their face. Anyway, let's go across to the end counter. Okay, so hopefully that little exercise of impedance and load and how it creates, wattage from voltage, a little sum. And if anyone, thinks it's all fake and mirrors, just go look it up on Google. You'll see it's legit stuff, it's Ohm's law. And maybe you should have paid attention at school if you thought, hey, school's boring. Well, guess what? If you really want to get into this industry, a lot of that stuff that you thought was boring actually becomes quite useful. But moving on to look at what an amplifier dyno does. Now, we spoke about this beast. This is called an AD1, like I said, made by Tony DMR, marketed by DA Engineering on the right here. SMD is the marketing arm that Steve Mead designs. Anyway, the head units that we got here on the left, the head unit on the left is a PMX2. It's rated as 50 by 4 into 2 ohms. Now, you look at that guy and you think, well, how can this little guy produce 50 by 4? I mean, it's electronics in there. It's got a DSP built into it. It's got a crossover network. It's got an equalizer. It's got 4 channels. It's got USB in, Bluetooth, auxiliary in, weather band radio. It's got Cyrus receivers. It's got FM, AM. It's got everything on it. You can plug an Apple phone into it directly and you can play music off it as well. We'll do that another day. We're actually going to go through all the marine products and show you what it can do. But what the purpose of today's exercise is to try and explain, well, how can that be 50 by 4? And this little guy, which is a 12-year-old amplifier, came in for a service, still running, is rated at 75 by 4 into 4 ohms. Now, we've got the amplifier dyno set up here. Left channel is playing left front channel of the PMX2, and the right of the amplifier dyno is playing also the left front channel of this old 404D. We've now moved on to about, I think the new model amplifiers have been out for the last 6 or 7 years, and they've had about 7 internal updates. Like I mentioned, Rockford's continually updating the internals. So the PC boards are updated, technology is updated, which is, what you're listening to. You're listening to the technology. A lot of people put on how can I say, you dress up the casing to make it look louder. It's like putting on a blingy exhaust pipe or something to make your car go faster. But actually, what's under the hood is what counts. So much the same for us. What's under the hood is what counts. So I'm going to run this amplifier dyno. We're going to do an uncertified test to give it a full advantage. Uncertified means it's running at 1% distortion. Certified is 0.1%. So we're going to do 1%. Reason being is 1% is kind of like the standard. Now, that amplifier is rated at that, but we also know that that is rated as by the manufacturer's chip, which is run into a non-reactive load. This is simulating a reactive load. Like I said, it takes 6 times the amount to drive a loudspeaker, and this is exactly what the amplifier dyno is doing. So I'm going to hit the button. If I hit the button, you'll see it says here, uncertified dyno track running at 2 ohm load. Any track, so we've got the correct track set up. Let's go. Okay. So now it's giving me the run. It shows me what it does. It tells me I've got signal. It will show me the clipping indicator, and it produced 27 watts, which is, hey, considering that chap is a little unit that big as 27, genuine RMS wattage, okay, by 4. Now, that means that you can run 8 speakers off that head unit, because it would run a 4 ohm speaker in parallel, would give you 2 ohms. That's exactly what I've done. And that's just off one channel. But now you're saying to yourself, it's rated at 50. This is rated, and I mean, we have amplifiers that are rated at 50, but this one happens to be lying around at 75 watts. Let's find out what this guy does, right? Exactly the same test, exactly the same track, and it's rated at 75 watts. Now, rightfully speaking, it should do half of that, right? But because of current, and current's the key here, let's find out exactly what it does. Okay, so now I'm going to hit the button and run the sequence. There she goes. 308 watts. Oh my goodness.
That's impressive.
Out of a 75 watt, 12 or 13-year-old amplifier. I mean, that's unheard of. And I mean, it's only 1% distortion. So you kind of think to yourself that that's not an indication of what current does. So that would be like your little motorbike battery, and this would be your car battery, using that analogy. And that's our entry-level amplifiers. Prime is the starting point. 12 to 13-year-old amplifier. I mean, our new ones will be way stronger than this. And then, of course, we've got the punch range. And this is the entry-level, smallest model, by the way. Then we have other models above this in the prime range. Obviously, we've got the punch range and then the power range. And we can do amp dynos all day long, and you'll be like, oh my goodness, this is the truth about what amplifiers produce. That's 308 watts. Now we're going to go one better. We've only got one channel playing, ladies and gents. Let's take it and bridge this guy. Okay, we're going to see what it does into bridge. Sorry, yeah, 4 amp per channel. Now we're going to go and run it into a bridge mode and see what it does. Okay, amplifier into a 2 ohm load. By taking the amplifier and putting it into a 4 ohm bridge configuration, which means it's going to see 2 ohms per channel. Now, a lot of people, I'm sure a lot of people know that, but a lot of people don't know that when you put a stereo amplifier into bridge, it sees half the load. So it actually produces more power, and that's if the amplifier can actually do so, if it's got a decent power supply to produce the current, like we explained. So it did about 308 watts into 4 ohms per channel, which is what we did on the first test. That was one channel shown. Now we're going to bridge that same front channel, and we're going to run it as a 4 ohm bridge. If you look at it, it says 4 ohms, but it's seeing 2 ohms per channel. So I'm going to start the amp dyno. Let's see what this guy can do, which is supposedly a 75 watt per channel amplifier. Here we go. Okay, so it's running into a slight clip 1%. And that's climbing 491. Oh my goodness, 550, my goodness, 633 watts, 661, 679. That's insane. 679 watts RMS from an old 13 or 12, 13-year-old amplifier. I mean, that's Rockford Fosgate's power. You cannot beat it. That's why we deliver the punch. People understand and they say, why does Rockford cost more? You're actually getting more rands per watt. This is the device that tells the truth. Anything else is just smoke and mirrors. Have yourself a good rocking day. Peace out.